Hi everyone. Bailey, I know you're on the webinar. Can you just let me know if you can hear me okay? Very good. Okay. Cool. So today's webinar is really a recap of the Qlik Analytics tour that we were part of recently. So Qlik did a bit of a roadshow around the US. So I think it was actually a global tour, really focused on the new sort of AI and ML capabilities that they're starting to build into the Qlik ecosystem. And it was really just to let people know about like what Qlik's up to, what they're working on, where they're going with this. So we did a few of these events on Qlik's behalf, and I'll just sort of do an overview of some of the content that we talked about at those events. So yeah, first piece I want to focus on is sort of what Qlik's doing with AI, ML, what they're doing with augmented intelligence, how some of the cognitive insights and chart suggestions are working and how you can get some value out of them. And then the next piece I want to talk about, and this is probably what we want to focus more on today, just because I know generally there's more interest around this area, is the Advanced Analytics Toolkit. So how you can get up and running with some predictive modeling in Qlik, and then also how you can take that one step further and use a platform like DataRobot to further enhance or further dive into the sort of machine learning and predictive modeling channel. So, sorry, let me just get my slides in order here. Cool, so just a really quick overview of who we are. My name's Scott. I'm a consultant with Pomerol Partners. We are about 6 years old. We started in London in 2013 and mainly worked in investment banking for the first couple of years. We've since grown out a team of about 70 to 80 people spread across our sort of UK base and also our US base, and we also have a small team in South Africa. And we're now working across many industries: manufacturing, supply chain, pharmaceuticals, healthcare, and also still working in the banking space as well. Yes, so we're quite spread. Our main office in the US is in Chicago, but we've also got a team in Denver and Kansas City. But our main focus in the US is really on the Midwest and Rockies territories. I'm just going to skip through this piece on clients. So I guess the first thing, and just to sort of set the scene, we just want to quickly talk about how data is transforming, data and analytics is transforming the way we do business, and sort of why this conversation is relevant. Sorry, I've just gone and got my slides out of order again. So what most people on this call will be finding, and most of our customers that we're dealing with day to day are finding, is that they have a lot more data at their disposal than they used to. Most of our customers are still dealing with just traditional data sources, ERP systems, CRM systems, planning systems. So they're not, most people that we're working with are not really subject to kind of web data sources, which is what I've sort of got in front of you. This idea that we're taking so many photos, we're making so many posts online. There's a lot more news coming out. It's short form, it's rapid. In terms of the business world, the demand that's changing is really how often people want their data refreshed, how, people have gone from month-end reporting to weekly reporting to daily to almost, I want live sales numbers coming into my dashboards as they're entered into our ERP system. So that's kind of the difference in demand and the shift that we're seeing in the business world. And what that means is that we need a different approach and a different set of tools to deal with that demand for live and improved data availability. Another thing that's sort of driving a change in the business world is the growth of self-service BI and demand for self-service BI. So we're no longer just building reporting at the centralized IT level. Self-service BI is all about having people at the far reaches of the organization with access to a governed data source where they can build their own reporting and their own views. And so that also requires a different set of tools and a different approach. So this is just a little stat that I saw that Qlik had put together. And this is just the idea that in the near future, we will have a huge number of data-driven interactions per person. I don't really know what sort of 5,000 data-driven interactions per person means, but what is important is that in 2017, it was only 300. So what we're seeing is this exponential growth in the amount of data that we're dealing with daily and the amount of data that we're using to sort of guide our decision-making on a daily basis. So before we get started on why Qlik has kind of doubled down on AI, we need to sort of set the scene and look at the impact that data is having on business. So we have the data, but what tools do we need to sort of actually use this data and create some value from this data? So I really like to show this slide here. So this is a slide that someone in sales at Qlik has put together, and I've sort of stolen it and use it quite often. And the reason I like to show this is because when people are showing off BI tools, they're often showing off the visuals of BI tools. And the visuals is really the part that has become very homogenized. These are 6 different common BI platforms. There's Tableau, Power BI, Qlik is in here. And the point of this is that it's actually really hard to tell them apart, and that the differentiation between BI platforms is really not in the visualization. So what does make Qlik unique in this space? And what does make Qlik unique, and the reason why we're closely aligned with Qlik, is because of this end-to-end sort of data pipeline, or this end-to-end process that Qlik covers. So from right on the left over here, where we've got original data capture and change data capture and sort of data cataloging and so on, through the analytics space in the middle, where we're doing data transformation and getting our data ready, and then delivery and insights over on the right, where we're actually delivering that information to the business through many different platforms, whether it be sort of in the hub, on mobile, through pushed reporting, through something like the Insight bot. And the piece that Qlik's really trying to emphasize at the moment is that the cognitive and machine learning technology that they're working on is going to touch all areas of this whole spectrum. So it's going to help and make suggestions right at the very beginning with the data capture, profiling data when you look at a new data source and making suggestions on how to transform that data, all the way through to the actual insights page, or the insights area, of making suggestions of how you should visualize that information to tell the story that you're trying to tell. So I just want to have a really quick look here at the evolution of business intelligence to sort of set the context of, why are we at the stage now where we're talking about self-service and how to promote and sort of drive engagement of self-service through the use of AI and ML. So, first generation BI, very centralized, controlled by IT. And what this sort of migrated into is second generation. And I'd almost say this is where Qlik came out. And the idea here was that, IT was still in charge of governance and sat in the middle, but they could push or they could let sort of business units have access to a governed structured data source and start to do their own analysis and build their own reporting. So we started to see things a bit more responsive. Business units could act a lot faster, respond to requests instead of the old cycle, which was push a request into IT, wait for it, get it back, and then that slow feedback loop. And then so the stage we're in now is really third generation BI, where these business units have a lot more control over their information, and then they're feeding out a governed platform or a governed data source to members of their organizations to actually build their own reporting. And it's this sort of architecture or this organization that you're seeing here. This is what's driven the need for Qlik to build some more sort of cognitive insights and put some guardrails within the platform. So as you get further out to the ends of the organization, you're sort of losing the ability to see exactly what these users are doing and to help them and assist them and educate them. So within the platform, we've needed more governance. This is why Qlik is sort of often going on about the use of master measures. And what you'll see shortly is the cognitive insights and so on that are being built into the platform. It's to help these users that are out at the periphery to guide them along, get them kickstarted, and maybe help those users that are less data literate that are at the ends of the organization. So in the sort of third generation of BI, there's a few different components to this. One is the democratization of data. So that's just getting data out to those far reaches at the periphery we just talked about. There's this idea of embedded everywhere. So instead of analytics just being a single destination that people go to, the analytics is being pushed out onto the web, internal websites, onto mobile. It's being spread and sort of embedded and delivered in many different ways instead of the old school sort of traditional packed reporting. But the piece that we want to look at today with Qlik is kind of the augmented intelligence piece and what they're doing on this front. So I'm just going to skim through this. I don't think we need to really tell everyone about why AI is important at the moment. It's AI is sort of all the rage, and it seems to be all I'm reading about or all that pops up on my LinkedIn feed at the moment. But the piece that I do want to emphasize is that what Qlik's done and their sort of approach to this is that instead of just building a sort of black box AI module that sits off to the side, what they've tried to do is actually bring the AI component into the platform and embed it across the platform. And the reason they've done this is that they're recognizing that the machine intelligence by itself is not actually that powerful. It's only powerful once it's combined with some human intuition from the users who are using their applications, and also combining that with just traditional data science methodology. And so it's when you sort of bring these components together, you start to get a sort of powerful tool that's actually usable and can generate some value. Another thing that I guess is kind of unique to Qlik and is really helping with the development of their cognitive engine is the fact that they have the associative engine already available, sort of built in and embedded into the product. Traditional query-based tools are not necessarily as not necessarily appropriate or built for sort of what we're trying to do with modern analytics, which is cognitive insights and predictive analytics generated on the fly. This really works well with the associative engine. So let me just flick through a few of these slides. I'm sort of using a slide pack here that we used during our presentation, but our presentation was sort of a few hours of an event, so we can skim through a lot of this. What we're showing here is really just the different parts of the platform where Qlik is embedding their AI capabilities. So we're seeing it in smart visualizations and analytics. So this is like suggested chart types and Qlik profiling the data, or learning from what other users have done in the past to try and suggest the types of analytics that are appropriate. It's sort of profiling the data so that in the actual data manager, when people are loading in data, Qlik can make better suggestions around how to transform that data. We're seeing it in, there's obviously the insight bot, conversational analytics, natural language processing and generation. There's a lot of AI components that Qlik's working on in this space as well. So what I want to do is just take a quick look at a Qlik application and just take a look at sort of what the cognitive engine is doing and what kind of insights it can generate. So this is just a standard Qlik application. I think this is one of Qlik's demo apps that come shipped with the product. We're just looking at some sales margin here by different sales reps, and sort of revenue here by different products. So if I just highlight some data, so just say I want to take a look at like this time period here, we've seen a really good run up in sales to this point, and then we've seen a pretty steady decline. So maybe we want to investigate, what's happening over this time period. And then maybe we want to focus also on these sales reps here that have, below target sales margin. So we've made some selections in our data set. And now what we can do is go up to the selections pane here. And what Qlik's going to do is it's going to profile the entire data set based on these selections, but it's not just going to profile the data for these selections. It's going to acknowledge these selections, but it's actually going to profile the data and generate insights based on the entire data set. So what's unique here is that in many other query-based tools, when we've made these selections, the remaining sales reps and the remaining time periods are essentially sort of hidden and cut off and forgotten about. And what Qlik's developed here is a neat way to actually analyze what data relates to our non-selected or excluded values. So for example, if I look at, we selected sales reps that had poor gross margin on their sales, so we're interested in cost. So Qlik sort of auto-generated some analysis here to look at cost based on different products. So what it's doing here is it's quickly letting us see like what is the impact of those products that these sales reps have not been selling. Is it proportionately higher or proportionately lower? So what we can do then is we can actually drill in and focus just on these selected products. So if I scroll down here and say reveal the data for the excluded values, I can actually see all of these excluded values because these sales reps haven't been selling them. And then maybe I actually want to forget these selections and I actually just want to focus on these excluded products. So I can instantly say select possible. And it's going to go and select these products. And then what I can do is jump over to insights up on the top right here. So for the first piece, selections, is really around highlighting information that's relevant to the exclusions based on my selections and trying to work out what those hidden insights might be. And then jumping over to the Insights tab, this is where Qlik is going to profile the data based on my selections, and then will suggest to me different chart types that I could use to visualize this information. So for a lot of developers, or most developers I've seen that I've shown this to, sort of instantly balk at this and say, I would never use this because I already know what I want to build. What I generally say to developers is I'm not suggesting that these visualizations are exactly what you want, but it's a great way to quickly build an app and get started. So you can load in a data set, and then you can take, so Qlik suggested this current year sales by product type, for example. So I can take a look at this chart, but I may want to actually change this to, say, I don't know, let's look at a different product dimension. I could change this to product group. And then I might not want to look at current year sales. I want to actually look at something like revenue, revenue versus last year's revenue, for example. So I can actually take that suggestion that Qlik's given and then actually go and sort of still tweak it using my, and this is the human intuition component so I'm working with the chart suggestions, but bringing my subject matter knowledge to the table. And now that I've made a change to this chart, Qlik's going to say to me, well, you've changed our suggestion. Do you want me to actually learn from this? So of course I do. I'm going to click learn, and then Qlik's going to acknowledge that. So maybe Qlik had chosen a dimension for this chart that wasn't actually appropriate, and that's not a reporting dimension that we're ever going to use. So I can actually go in and sort of tweak these visualizations and tell Qlik to learn from them. And then going forward, Qlik is not going to, won't make another chart suggestion using that dimension. And what you'll find is that if you have multiple users of an application, Qlik is going to learn, the learning is centralized. So when Qlik's had exposure to a certain data model for a while, it starts to get really good at knowing what the reporting dimensions are and what kind of metrics people are wanting to build, build visualizations and apps on. So once I've sort of tweaked this visualization, I can then go and add it to either an existing sheet, or I can say, create a new sheet. So I can do the same thing here. I can go and, add, I've got my new sheet here. I can go and add a couple of these other visualizations. I could also say to Qlik, look, this doesn't make any sense to us. I don't want you to suggest this. So can you hide this? So it hasn't actually deleted it, and it's not learning from it, but it's hiding this for the time being. So that's kind of a quick, just a really quick overview of what the sort of selections and insights areas are doing and where the value is. The main value, or the main sort of the main aim, I guess, behind this insights area is really to help the self-service users who maybe don't understand the data set that they're dealing with perfectly and need a head start. So the idea is that Qlik can profile the data better than a human can quickly, and it can instantly see, based on things like the distinct number of values within a field, it can try and work out whether this is a dimension or whether this should be a measure. Are the values text, or are they categorical, or are they numeric? So it's sort of, Qlik gets a bit of a head start at profiling the data, and then with that input and feedback that the users put into the platform, it can tweak and hone its suggestions that it can put forward. Cool. So that's sort of what Qlik's doing on the augmented intelligence front. I think it's early days. I mean, even though it's been out and available for a while now, I think the first bits came out at the start of 2018. I'd say it's only really starting to become quite usable and powerful, and I'd expect it to get a lot better over the coming year or two. So it's definitely a sort of watch this space. So the next piece I want to talk about is AI and ML, but more in terms of predictive analytics and how to get started using predictive analytics, machine learning, the advanced analytics toolkit, and sort of where we can go with that. So I'm going to skim through these bits. I mean, we don't really need to define, I think, what AI is, but the 10,000 foot explanation is that AI is essentially systems that can perform tasks that ordinarily requires human intelligence. An AI system can make a decision and take action, whereas we really define machine learning as learning from the past to predict the future. And generally, the target that we're working with is quite specific in a machine learning exercise. So this is just a really simple example. Here we're looking at square footage of apartments or houses, and here's the sales price. So the idea is we have some history. We can draw a line of best fit through this data, and that's essentially going to be our model. So we can take some historical data, we can build a model based on that history, and then in future, I can come along with a square footage of a house, and I should be able to use my model to predict the sales price for that property. So this is a ridiculously simple example that's not really relevant. I mean, different cities are going to have a different price to square footage ratio, for example. So the problem here is that reality is more complex than one variable. So as soon as we start to get multiple variables, so in our house price scenario, this might be the city, it might be the time of year that you're trying to sell the house, it might be the age of the house. All of a sudden, it starts to get quite complicated, and building a simple regression model in Excel is no longer, relevant. So just in terms of the advanced analytics toolkit in Qlik, I mean, it's really reliant on standard data science principles. So, a lot of regression models. We can do classification models. Let's just flick through a few of these. We can do clustering, which is really helpful when we have a large number of data points in our data set, and we want to start to see the patterns and relationships between clusters of those results. So how is machine learning different from traditional data science? I mean, in principle, it's not. I mean, statistical data science methodology remains exactly the same. These are the principles we're relying on. The difference really with machine learning and where machine learning's going is that we can create a huge number of models at pace, and we can test and deploy these, and we can essentially fail fast. So the idea is that traditionally we had to build our predictive models by hand and use the techniques that we'd probably used in our past projects. We have a lot of tools now that can help us build models really quickly on the fly. We can see if they work. If they work, we can pursue them, and if they don't work, we can dump them and sort of move on. So that fail fast methodology naturally gets us to better models quicker, better results at less cost. The other piece that's really changing in the predictive analytics and machine learning space is that a lot of the tools are becoming self-service. So instead of needing a data science background to be able to produce models, you really just need some analyst skills. If you can prepare a data set and you have a good understanding of the subject matter of the data set, then there's self-service tools that can let you build predictive models. So, I mean, Data Robot always refers to this as citizen data scientists. And what they're really talking about is taking analyst teams that don't have data science experience and giving them the tools to produce the output that would typically be generated by data scientists. So in terms of predictive analytics and machine learning projects, I mean, the workflow and process, regardless of the tools, it kind of remains the same. It's sort of this iterative process of defining what your output is, or defining what you're trying to solve, preparing the data, building models, and then analyzing and interpreting the results. And then we often spend a lot of time in the middle here in this sort of iterative, feedback cycle of honing and refining our models until we've produced a model that either sort of hits our success criteria or hits a certain benchmark that we were aiming for. So there's kind of two stages to any predictive analytics project. We've really got training and predictions. So we need to create a model based on historical data that we can use to understand the impact or importance of the different variables in our model, so that in our new data set that we want to score, we know how much weight to give to each of those variables, and then we can take that data set and score it. So yeah, there's training and scoring. So then we bring these two pieces together. In terms of people getting started in Qlik, with predictive analytics and with machine learning, this is kind of the approach that we always recommend. The first thing I always recommend people to do is just start building some trend lines, some linear regression models, do what you can in Excel and start building some forward-looking predictive models just based on your historical data. And the idea here is just to get a flavor for what kinds of things you might want to predict, what kind of features or variables might be important to consider in your models. There's quite a few functions that just exist within Qlik that people don't really use or explore. There's a lot of statistical functions for calculating error and so on, and there's functions for drawing, lines of best fit and so on. The next stage beyond that is really, where did I jump to? Sorry, let me just jump back to here. Sorry. Cool, yeah. So the next piece really is to start using the Qlik Advanced Analytics Toolkit. So if you have a Qlik server instance, all the components you need to set up and use the Advanced Analytics Toolkit are free and available. They really just need to be installed. So there's an extension that needs to come onto that server, and then you also need to be able to connect to an R server. That R server can be installed on the Qlik server itself, or you can install that on a separate server and communicate with that server. In a sort of testing and development environment, I often just get it installed all on the same Qlik Sense server to get up and running. If we were pushing that into production, we'd want to split it out onto a separate environment, so Qlik wasn't fighting with RServe for the same resources. And then, once people have really started to prove some value with the Advanced Analytics Toolkit, and once you start getting along in your model building exercises, you start to see there are some gaps. The Advanced Analytics Toolkit is quick and easy to use, but there's definitely some gaps. It's definitely a bit of a black box environment. It's hard to know what's going on with the model in the background and what's generating the output that you're seeing. And that's where you can start to look at fully automated machine learning platforms like DataRobot or Big Squid. Microsoft has some great options in that space as well. So the Advanced Analytic Toolkit, kind of how does it work? So Qlik connects to R live to conduct analysis. So what happens is if I have a data set, Qlik is, every time I make selections and filter my data set down, Qlik is sending that little subset or hypercube to the R server and saying, change your predictions based on this subset of data and then send it back to me. And we'll take a look at how that works shortly. So there's a server-side extension that you need to install on the server. But the main point with the Advanced Analytics Toolkit is that it's a great way to extend Qlik, and it's essentially free or comes at very little cost. So if you are wanting to get into predictive modeling, there's no budget available currently. It's a great way to start a project, show some value, even if it's just a quick and dirty model and the results aren't amazing. It's a great way to show what is possible and sort of garner some enthusiasm and support for getting budget to explore predictive analytics and machine learning, more in depth. So what I want to do is just jump into a Qlik application here and take a look at a simple use case we've got. So we're looking at a heart disease data set. So we have a selection of patients that have come from sort of a doctor's surgery, and these are people who are at risk of having heart disease. We have things like the what sex that person is, and then how they've scored against a whole lot of medical indicators that kind of relate to heart disease. So this is just a visual that kind of explains how the data transfer is happening. So on the Qlik Sense side, what's happening is when I filter my data set and make selections, that subset of data, that hypercube, is being communicated with the R server, and R is running the predictions on that and then sending that back to Qlik in real time. It's a little bit different to how sort of a batch processed model might work, where for example, I might have a sales data set, and once a day we want to run some kind of predictions on that data set, where I have a pre-trained model. I send a scoring data set to that model, and it scores that data set based on my training model and sends it back, and I visualize it, but it's essentially static and not responding to my filters. So one of the objects that's part of the package, and I'll just show you this object here itself. This here is essentially the extension. So that extension just works like any other extension, sits here in custom objects under extensions. And then I can see one of the first ones here is this advanced analytic toolbox. And then within the extension settings itself, if I go to analysis settings, I have a range of different analysis that I can filter on. So here I want to look at classification, and I want to look at a correlation heat map. But there's lots of other options under these settings here. So the reason this is really helpful is what this is really showing me is, based on all of the different variables that in my data set, I want to see how these are related to the target. And essentially the target is does this person have heart disease or not? So what I can see is some of these variables in particular, it's sort of more correlated with the target than others. So for example, if I look at this telic here, is essentially like the maximum heart rate, or CP here is chest pain. We can see both of these are very highly correlated with the target. And then there's some other variables in this data set that are not very correlated. So cholesterol, for example. I mean, I'm no doctor, so I don't know. I would have thought maybe cholesterol was more correlated. In this data set, it doesn't seem to be. The reason that this is valuable is, if we're wanting to predict, do a sort of regression analysis and predict the likelihood of someone having heart disease, we might think that we know which variables are contributing towards the target, or towards that patient having heart disease. But what we often find is that when we build a correlation matrix like this, we get a few surprises. There's often a few variables that are contributing to that, or correlate higher to the target than we actually realize. So we might start with 50 different fields in our data set, and using a correlation heat map, this might let us boil that down to, say, 10 or 15 fields that we want to focus on. So it's a good way of just getting a quick overview of our data set, working out what might be important, what might not be important. So another thing we can do here is build like a cluster analysis. So what we're looking at here is sort of max heart rate against different age people. And obviously we've got, we should see a slight downward trend in that the max heart rate should be a lot higher for these younger people than these older people. If we've got tens of thousands of different patients, seeing all of that squished on a chart together is not that helpful. So what we've done is we've actually clustered these into 5 different groups. So once again, if we go and actually have a look at one of these objects, it's just the advanced analytic extension. So it's only one extension, but we've chosen a clustering object, and we've chosen that we want a k-means cluster, and we can fill in here that we want to split this into 6 clusters. So I just want to give you a taste of the kind of settings that you can control through the user interface itself. So there's not really any configuration that's going on in the background. It's really, and this is what makes the Advanced Analytics Toolkit a great self-service tool. While this is limiting to an extent, because we only have control over limited things, it does help people who have very little data science expertise build or use these different chart types and sort of get running quickly just by using the settings that are available in the front end. So just to show a couple of other chart types we can use, we can do like a logistic regression analysis. So we can see all of our different variables down the left here. We've got our confusion matrix for the problem here. So this here is let me just show you the object type. So yeah, logistic regression analysis, which falls under classification. We can also build decision trees. I think the decision tree output for this particular model was actually terrible, but once again, for certain models, a decision tree is going to be really relevant. So, this object's available. And it's also a great visual way of representing the flow through a model. Yeah, I can see that the output was, or the accuracy of this decision tree model was about 53%. So it's almost a coin toss. So it didn't actually work very well in this case. So before I sort of jump on and sort of show how Qlik can connect into other machine learning platforms, I just want to take a look at a couple more examples. So we can also do time series analysis using the Advanced Analytics Toolkit. So here we're looking at a Walmart data set of sales information. So yeah, we've got some historical sales here. I think these peaks that we're seeing must be, this looks like sort of Black Friday and Christmas, I think, and we're seeing that annually. So the object that we're using for our time series analysis here, we're just using a Holt-Winters model. So time series is its own category, and then we've got a range of different time series charts that we could build. So a Holt-Winters model is really trying to pick up three different aspects. It's trying to pick up sort of the typical value or average. It's trying to work out the slope or the trend over time, and it's also trying to pick up any cyclical patterns that are happening over and over again. What we can control in terms of the front end settings here. So with our forward-looking piece at the end, we can dictate what confidence level we want. So what our sort of margin of error should be. We can determine how many periods we want to forecast forward. We can also determine in here whether we want the model to pick up, seasonal trends, or how we want them to deal with those seasonal trends. So what this model here is looking at is like our entire, it's looking at our entire data set. What we could do is we could go and filter on a particular store. So I know the store here, 36, has a trend that's very different to the bulk of the data set. It's got this very steady downward sales trend. So what's actually happened here is when I've selected store 36, Qlik has actually taken that data set, sent it to the R server, and the R server has created this prediction in the middle here and actually sent this back to Qlik, and it's being visualized. So sort of on the fly, as you make these selections, the model is being rebuilt, like sent to the R server, rebuilt and visualized. So this is something that's the real sort of value in this is there's not really any point in creating a single model for all of our stores because that model does not work for store 36. So the idea here is that we can build models unique to our selections on the fly, and that's obviously going to get us to significantly more accurate results than just using a blanket model to score, all of our stores. Likewise, we've got a whole lot of different departments in the store, and some departments actually might be trending up, others are trending down. So we want to be able to build models on the fly specific to our target that we have in mind. So, and one of the, and I just want to highlight a few of the gaps or a few of the downsides of the Advanced Analytic Toolkit. So one problem that we have with this is that we don't necessarily have much control over the training data set and the prediction data set. So when I go to throw this data set to the R server and build a model, what I can do is I can say, and I'll see if I can show you an example of this here. I can actually determine how much of the data set do I want to be training and how much of it do I want to be predictions. So let me just see if I can show you an example of this. So in here, I can say treat the first 0.8 or 80% of records as a training data set. I could turn this up to 95%, for example, and it's going to rebuild this model with 95% training, and the remaining 5% is being scored against that training data set. What I can't see here is which 95% of my data set are we using for the training? How is that being selected? Is it random? Is it truly random? I mean, so the problem with this, and I've seen this a few times, is that what we've noticed in the past is that sometimes like a good example here is that I know roughly what the proportion should be between true and false in this model. And what I should see that in my training data, so we had 51,000 records in the training data set, and then we tested that against 2,600 records. I know roughly what the balance should be between true and false. And sometimes you might see that that balance is way out. And what that's telling us is that, well, the prediction data set that was chosen, at random in inverted commas, sometimes might not be perfectly representative of your entire data set. So there's a few things you can do to tackle that. You can do some additional shuffling of your data when you load it into Qlik in the first place to ensure it's absolutely truly random and there's not sometimes the way your data might be loaded in, it might naturally get loaded in by the order that it was entered into your ERP system, or it might be by the order date, or it might be ordered by something that's going to sort of harm your model. Like we might be looking at 10 years worth of sales opportunities, and naturally all of the older opportunities are either won or closed, and the later opportunities are actually open. So without realizing, we don't have a perfectly distributed data set. So that's something that definitely needs to be looked out for. So another piece of this is to think about is this is giving us a model and the accuracy for a training data set, but then how do I take a new set of data and score it against this model itself? And that's something that's not that easily done in the Advanced Analytic Toolkit. So what I actually need to do really is I've built this model on about 50,000 historical records. I then really need to go and take the coefficients that have been produced, and I can actually take those coefficients and manually go and apply those to a new data set. So this is new data that I want to score. I can actually create that equation manually in my load script and actually create this regression problem or create this probability. So that's a bit of a manual step. It would be ideal if we could train a model in the Advanced Analytic Toolkit and then use that trained model to score new data. But there's sort of a manual step in being able to run a problem like the one I've just shown you. So just jumping back, another sort of piece I wanted to look at, and I might just take a look at a couple of slides here. So there's quite a few challenges that come in terms of building predictive models. A couple of these we've already talked about, but scarcity of people who actually have the skill sets to be able to prepare and analyze and build models. There's often a cost impact. It often takes a lot of time to build models, and the first version of the model often pops out really quickly, but to actually get to the final honed perfect output can take a lot of time and cost, and obviously that involves a lot of risk. Another piece is, how do you actually get these models productionized and deployed? And then once they're deployed, how do you monitor them, make sure that the model that you trained, that you're scoring against, is still relevant, and that your data hasn't shifted so much that your trained model is now irrelevant, or has gone stale. So a couple of things that you can do to get around that problem, I guess, is look at other platforms like DataRobot. So DataRobot is a full machine learning platform that sits outside of Qlik, but what Qlik can do is actually connect to DataRobot using APIs, so we can actually pass a data set to DataRobot. So I'm just going to demonstrate how that works in a quick example here. So this is a connector that one of the teams at Qlik has built, and so I have my data set loaded into my app here. So I can go and pick a range of these variables. I obviously need the target in there in order to train my data set, gender, age group. I can grab whatever of these fields that I want. I can call this, Scott's test model for webinar. I need to throw in my API token that's going to let me connect to DataRobot. And of course, because this is a demo, my token here does not work. Okay, cool. So what we'll do is we'll just jump into the DataRobot platform automatically. So what would generally happen is I put in my API token, and what Qlik would do is it would pass this data set to DataRobot, and then over in the DataRobot platform, it would actually kick off a model using my data set, and then we'd be able to see the different tasks and the different models being built. Let me just see if I have. So what I might do here is I'll just see if I can drag that data set in manually so that we can see that the model's building and how DataRobot deals with that data set. Where are we? Sorry, let me just find my data set here. Here we go. Cool. So if I actually go up here and say I want to create a new project, what I can say is I want to load some data in from. I can just drag a file. So I've actually got a different data set here that's for diabetes patients, and it's kind of doing the same thing. It's trying to predict. It's actually trying to predict hospital readmissions for patients that have been admitted with diabetes. So when I drag the data set in here, the first thing DataRobot does is profiles the data set and tries to work out, what all the data types are, which are categorical variables, which are numeric variables. It's going to start to look at the importance of the different variables that are in that data set. And then once it's profiled the data, it's going to show me how it's interpreted the data set. So I know that I'm trying to look for the, let's see, I'm trying to remember what is the field name. I think it might be called readmitted. There we go. So this is actually the target that I'm trying to find, and I can run this fully on autopilot. So I can see here I'm in autopilot mode, or I can actually go in and sort of set all the different parameters for how I want DataRobot to run. So the idea here is, like, for a data scientist, the platform has all of the power and functionality that you need to sort of tweak and hone and engineer your own models. If I'm an analyst who has no data science or model building expertise at all, I can just run DataRobot purely in autopilot mode. So what we're going to see here is DataRobot's going to work out which models it thinks are best to run against this data set. And then it's going to start creating a backlog of these models. And it's probably going to run, I think it will probably run about 60 or 70 models against this data set. And it's going to take about 5 minutes. And so the real value here is that instead of us choosing a model and building a model by hand and running it against this data set, we're going to end up with, currently we've got 39, I think, models in the queue here. And DataRobot's going to start running all these models, and it'll instantly start popping these into the model leaderboard as they complete. And the metric, we've got log loss, like DataRobot's profiled the data and chosen log loss to be the most appropriate measure to grade our model accuracy on. But we can obviously go and change this if we have some other insight that would let us know that there's actually something else that we should be grading these models on. And then the model leaderboard is slowly going to tick up and up and up as the models are finished. And eventually DataRobot's going to say, I think this is the model that you should push to production based on things like the accuracy, how long it took to run, things like that, the amount of error in the model. So I can just jump over to a different project here, one that, so actually here, finished 10K diabetes. So we must have run this at an earlier stage. So we can see that this model, when we threw this data set in here just on autopilot, DataRobot chose 58 models to run against this data set, and the one that it chose that it's sort of recommended for deployment is this extreme gradient boosted trees classifier. And now that we have a model here, we can actually go and sort of we can go and interrogate that actual model and try and dig under the bonnet and see like what's driving that model and why did DataRobot choose this as the most appropriate model. One thing that's always really interesting to look at here is feature impact, and this is kind of doing something similar to what the correlation matrix was doing in the Advanced Analytics Toolkit. So here, where we were trying to see how important are these variables against the target we're trying to predict, DataRobot's doing something similar here. It's saying what were the impact of these different features in our models. And what we can see here, so in this hospital readmissions data set, the most important thing that contributing to the output was the discharge disposition. So why was this person discharged? So that actually makes sense. We can see the second most important thing was the number of times they've been an inpatient. So when it comes to, if I had 300 different data points in my data set, throwing it into DataRobot and just seeing the feature impact alone could help me identify sort of the 10 or 20 variables that I want to focus on. And then often you'll end up with a lot of noise at the bottom, a lot of variables that are having very little impact on the accuracy of the model, and we can sort of remove those so that we can create a slimmer and light and nimble model. So that's just a really quick look at DataRobot. In terms of sort of planning for success, I guess, in using machine learning tools and using the Advanced Analytics Toolkit. I mean, these are kind of the steps we go through, and this is kind of the steps I recommend people who are using Qlik and are Qlik analysts to go through so that they can generate a project that can deliver some value that they can take back to the business and then build some momentum and support around. So I think that's about all we've got for today. If there's any other questions around, I mean, it's really hard to do a session like this with a really wide audience, some more technical. I know there's a couple of people more on the sales side on the call. So we've sort of just swept past everything with a broad brush. If there's any specific questions, especially around how to set up the advanced analytics toolkit and get that running in your existing Qlik environments, just shoot myself a message. I'm on scott@pomerolpartners.com. And yeah, we'd be more than happy to sort of send you in the right direction, or at least get some resources over to you to help you get things going yourselves. So thanks for your time, everyone.